Representation of graphs in graph theory is most important topic. In this topic, we will learn how the given graphs can be represented. Let's we see one by one here. Generally, there are two ways to represent a graph with the matrix. That is adjacency matrix and incidency matrix representation. Now, coming to representation of indirect graph, first way is adjacency matrix representation. What is adjacency matrix representation is in an undirected graph G, it consists n vertices. Then its adjacency matrix of a given graph is n by n matrix. Suppose that n by n matrix is capital A equals to Aij. Here Aij can be defined as Aij is equals to 1 if Vi comma Vj is an edge, or Vi is adjacent to Vj. What is the meaning of Vi is adjacent to Vj? Vi is connected to Vj, then we take the value 1. If there is no edge between Vi and Vj, then we take the value as 0. Okay. If there exists an edge between vertex Vi and vertex Vj, where here I is a row and j is the column, then the value of Aij is equals to 1. If there is no edge between the vertex Vi and Vj, then the value of Aij is equals to 0. To understand this adjacency matrix representation, let we look at the example. Find the adjacency matrix M of the graph G shown in the figure below. This is the given graph. To this graph, first of all, it is directed graph or undirected graph. Clearly, this is undirected graph. Why? Because in every edge, there is no arrow mark. On every edge of this graph, there is no arrow. That's why this is undirected graph. So to represent the undirected graph in an adjacency matrix, look at the how the adjacency matrix of the undirected graph is there. Look at the diagram here. How many vertices are there? A, B, C, D. Total, there are four vertices. That's why we can write the matrix means adjacency matrix of order 4 by 4. Okay, see this. Since the graph G consists of four vertices, therefore adjacency matrix will have a 4 by 4 matrix. The adjacency matrix is as follows. Here, four rows and four columns, A, B, C, and column also A, B, C, D, A, B, C, D, A, B, C, D. Okay. Observe this graph carefully. Here, the vertex A is connected to the vertex B. Then we take the value as 1. If the vertex A is not connected to the vertex B, then we take the value of 0. Okay. So let's have a look at the adjacency matrix here. A, A, A is not connected to A, that's why we take the value 0. AB, A is connected to B, that's why we take the value as 1. A is connected to C, that's why we take the value of 1. A is connected to D, that's why we take the value of 1. Like as B, C, D. So this is adjacency matrix of the given undirected graph. Now look at the another representation of the graphs, that is incidence matrix representation. Now the incidence matrix representation, if an undirected graph G consists of n vertices and m edges, then the incidence matrix is an n by m matrix. Suppose the m by n matrix can be taken as the C, that is equals to Cij, and is defined by and is defined as Cij is equals to 1 if the vertex Vi incident by an edge Ej. Then we take the value 0 otherwise. There is a row for every vertex and a column for every edge in the incidence matrix. That means rows can be taken as vertex can be taken as rows, edges can be taken as columns. Okay, so there is an important point here. The number of ones in an incidence matrix of the underrated graph here means without loops is equal to the sum of the degrees of all the vertices in a graph. Okay, so to understand this process means incidence matrix representation of underrated graph, look at the example here. Consider underrated graph G as shown in the figure below. Find the incidence matrix. This is clearly underrated graph. To represent this underrated graph, the second method is incidence matrix. So here, vertices of this diagram can be taken as rows. Edges of this diagram can be taken as columns. That's why how many vertices are there? V1, V2, V3, V4 means total 4 vertices. How many edges are there? E1, E2, E3, E4, E5. There are total 5 edges. That's why this is 4 rows with 5 columns. Okay. The underrated graph consists of 4 vertices and 5 edges. Therefore, the incidence matrix is an 4 by 5 matrix, which is shown in figure. Okay. Next, representation of directed graph. Just before we learn the representation of underrated graph, now we will learn the representation of directed graph. For a directed graph, there are for each graph there are two ways. One is adjacency matrix representation, and second one is incidence matrix representation. So for a directed graph, what is adjacency matrix representation? If a directed graph G consists of n vertices, then the adjacency matrix of a graph is n by n matrix. that is capital Aij, and is defined as Aij is equals to 1 if Vij is an edge. That is, Vi is initial vertex and Vj is the final vertex. Aij can be taken as 0 if there is no edge between Vi and Vj. There are some important points here. If there exists an edge between the vertex Vi and Vj, with Vi as initial vertex and Vj as final vertex, then the value of Vij is equals to 1. If there is no edge between Vi and Vj, then the value of Vij is equals to 0. Here, the number of ones in the adjacency matrix of a directed graph is equal to the number of edges. To understand this adjacency matrix representation for the directed graph, look at the example here. Consider the directed graph shown in figure below. Determine its adjacency matrix MA. Adjacency matrix name is MA. Clearly, this given graph is a directed graph. Why? Because on each edge of this graph has an arrow mark. That's why this is directed graph, or sometimes it is also known as digraph. Okay. So for this directed graph, we will write the adjacency matrix. Look at this. Since the directed graph G consists of 5 vertices, therefore adjacency matrix will be 5 by 5 matrix. Here the adjacency matrix name is MA, 5 rows with 5 columns like this. Next, the second way of representation is incidence matrix representation for directed graph. In a directed graph G consists of n vertices and m edges, then the incidence matrix is an n by m matrix C, and is defined as where Cij is equals to 1 if Vi is the initial vertex of an edge Ej. We take the value minus 1 if Vi is the final vertex of the edge Ej. We take the value as 0 if Vi is not incident on an edge Ej. ఒక ఎడ్జ్కి Vi అనే వర్టెక్స్ ఇనీషియల్ వర్టెక్స్ అయితేనేమో అక్కడ వాల్యూ 1గా తీసుకుంటాం. ఒకవేళ వర్టెక్స్ విఐ అనేది ఎడ్జ్కి ఫైనల్ వర్టెక్స్గా ఉంటేనేమో దాని వాల్యూ 1గా తీసుకుంటాం. ఒక వర్టెక్స్కి ఎటువంటి అది ఆ వర్టెక్స్ ఇనీషియల్ వర్టెక్స్ కానీ ఫైనల్ వర్టెక్స్ కానీ కాకపోతే ఒక ఎడ్జ్కి, then we take the value as 0. So look at the example here. Consider the directed graph G shown in figure below. Find the incidence matrix Mi. Observe this graph carefully. Is this is a directed graph or undirected graph? Yes, clearly this is undirected graph. But given, assume this as directed graph. Okay. How we are going to write the incidence matrix of this directed graph? Look at the solution. The directed graph consists of 4 vertices and 5 edges. That's why we are going to write the incidence matrix as 4 by 5 matrix, which is given below. Here vertices represented as rows and the edges represented as columns. Look at the diagram carefully here. We assume Vi is not initial vertex of Ei. We assume V3 as initial vertex. Suppose you may assume Vi is an initial vertex of the edge E1, then we write the value as like this. Here I assumed as Vi is not initial vertex of the edge E1. Vi is the final vertex of the edge E1. That's why I am going to write Vi E1 means first row first column element as -1. And coming to first row second column element V1 E2. So here for the edge E2, V1 is not the initial vertex or V1 is not final vertex of the edge E2. That's why I am going to write V1 E2 value as 0. Like this, V1 E3, V1 E4, V1 E5. Look at the V1 E5 here. For the edge E5, V1 I assumed as V1 is the final vertex of the edge E5. That's why I am going to write V1 E5 as -1. You may assume V1 is also initial vertex and another vertex can be taken as final vertex. Okay, like this I am going to write the incidence matrix of the directed graph. Okay, thank you.